All right. Well, here we are. The physics review recap live stream of, well, what is today? Thursday, March 19th, day 3 of eLearning. So let's see what we got today. Well, so this past week, we've done a couple lessons. First of all, how y'all doing? Hope you're doing well. This hasn't been easy, is it? But just keep on top of this stuff and physics will take care of itself. All right. Ask me questions, whatever you need, and I will help you in any way that I possibly can. All right. So I feel extra bright today. I'm not sure why. Oh well. Just make sure my stream health is a little bit on the slow side. 1, 2, 3, 4, 5. That's not too bad, I suppose. Well, all right. Well, let's recap then. So to begin with, we start with how electricity works. So hopefully you got that, you watched that video. And you got to see a little bit about how the battery basically provides a push to push the charges by squishing them together and forcing them together. And they all repel each other and push each other. And if you put a wire or any other conductor and give them a place to go, a path back to the other side of the battery, they will follow that path. And you get what's called a circuit. And then we looked into, well, what is all this stuff? Ohm's law. And unfortunately, it was something brand new. We didn't get a chance to talk about that in class at all. But Ohm's law is just the relationship between voltage, which is that push, current, which is the flow, the amount of electricity, the amount of electrons, and the resistance to that flow called, well, resistance. So that was Ohm's law. And as you can see, we got some practice, we got video walkthrough, and many of you have been taking this quiz. Continue with that. So if you haven't taken it yet, you definitely want to do that soon. Okay, don't let this fall. Don't let this pile up on you. Okay, so you don't want to be working over spring break, right? Because I'm sure we all have plans that we had canceled. So yeah. Plus, well, things are, yeah. We'll see. But then yesterday, insulators versus conductors, I kind of walked you through that on the stream. And so if you would watch the stream from yesterday, you can see my recap of that. Also, Mr. Knott, another physics teacher, was nice enough to put together a little video about how to do that and the walkthrough for that. So that brings us to today, the review guide for the test. Okay, I'm not going to put the test up linked until tomorrow. Sometime probably after 10 o'clock or so, I think I'll put the link up for the test. And 10 o'clock in the morning, of course. And then you can take it then. If you absolutely want to take it now, you want to take it earlier, just send me a message, and I can send you the link individually. Because if you've got plans or something and you want to just get it done with, keep in mind you pretty much get one shot at this test. And it is not like the quiz. We can retake it over and over again. So make sure you are ready for it. All right, so that's going to be tomorrow unless you send me a message for sooner. I just want to point out that, where did it go? Well, I got the review guide here. Apparently I closed it, so let me reopen it again. So here's the review guide. Your best bet is to do what I'm about to do. You can print it. If you have a printer, please. If you haven't yet, please definitely print it up. You can type it up and write on it. And when you get done, just take a picture of it and you could submit it for credit. But what I would like to do is open it in the desktop app, just like right here. Click on that. It should open it for you, especially if you're on your student device. And now you can save your very own copy. So what I would do is File, Save a Copy, Save as a Copy, and then you can have your own. Then you can write on it and do what you want. You could use your stylus to write on it, just like a lot of other things. Because Word is a little funky when it comes to writing on it with the stylus, sometimes what I like to do is I will actually print it to OneNote. And if you print it to OneNote, well, it prints it to OneNote, and OneNote is amazing for writing on. I do a lot of writing on OneNote, and with my stylus, I mean with like online digital writing. So that is an option for you. In fact, any of those are good, but let's just kind of like really quickly go through this because, well, we'll keep this as short as possible and as long as needed. So if you've got questions, I'm just going to verify that that this works. So I'm going to just say hello, and we should see, there we go. All right, so it is working. So if you got questions, definitely please send me a message. Just let me know what you need. Okay, so as you can see on the test, you should expect, this is again for regular, it's not for honors. Honors is going to be we're in different places. But if you're in my afternoon classes, period 4, 5, and 8, this is what we're doing. We're just kind of finishing up the electrostatics unit. This also includes, actually I probably can change this a little bit, and circuits. So circuits, I think I spelled that right. Looks wrong. So for the first part, I mean, we're going back to, and I said this yesterday, kind of in a preview, what electron is, all this stuff like that. Negatively charged object it's going to end up having more electrons than protons, because that's why it gets negative. And a positively charged, has fewer electrons, and so on and so forth. Like charges are going to repel, opposites are going to attract. A neutral object and a charged object is going to attract, and two neutral objects will not interact at all, if you remember. Okay, so, and by the way, all this is, do I even have a key linked on there? I might not at this point. Let's just close that. And it looks like not just yet, but these videos will walk you through all the questions. Okay, so that is the key. That is going to be our key for this. So going back to this. Now this is where it's going to be really nice. Oh, by the way, electric field lines always go away from positives and toward the negatives. All right, just double check that. I do have notes and all that online, but again, probably your best bet is just to watch the review, and you'll get walked through this. Mr. Knott does a good job walking through it. Okay, then we get into Coulomb's law, and if you increase the charge, remember charge is just a direct relationship. So whatever happens to charge, that's what happens to the electrostatic force between them. If you charge something up more, it's going to get stronger, and the more strength you have, the more strength something has, the stronger it could push. And the weaker it gets, the weaker it'll push proportionally. Distance is the one where it's the inverse square, and we've taken several quizzes on that, done some practices. That's the one with that data table, where like if you take if you have half the distance, then you're going to have 4 times the amount of force. If you have a third of the distance, you're going to have 9 times the force. What's 1 knot here? So if you quadruple, you have 4 times the distance, you're going to have 1/16 the force. Okay, so you have to inverse it, flip it over, in other words, and square it. So that's what this is going on here with Coulomb's law. Then, of course, we had the equation. I'm going to unitalicize that because it just looks funny to me. Oops, get it all. And so this is the equation we used, where K is 9 times 10 to the 9th, 9e9 in a calculator. And so one thing, like I said, we were very good at putting stuff in the calculator. And most of you are good at being able to pick out what's what, but this is going to help you with like what's what. So like, what is the symbol for distance? It's the lowercase d. What's the symbol for charge? Well, it's Q1 and Q2 and then K. So all that to say, got a couple practice questions for you. So I would definitely recommend trying them out. Write it out. Okay, remember what we said about writing things out? It helps you focus and helps you keep things straight in your mind, so you don't have to or you don't accidentally miss something or make a mistake on something. And by writing it all out, whoa, that's definitely not what I wanted to do there. There we go. By writing it out and listing everything, it's going to be very, very helpful for you. So especially for keeping things straight and getting it right, because yes, you will get stuff right if you don't write it out most of the time, much of the time, but you're more likely to make a mistake if you don't write stuff out ahead of time. All right. Then, and this is where part 1 would end. If you stopped here for part 1 for Mr. Knott's playlist, which not playlist, his video solution, this would be up through this part, up through Coulomb's laws right here. All right. So then that didn't do anything. So then we move on to part 2, which was all the electricity stuff, the non-static electricity, the flow of electron charges, the current. So VI and R is going to be voltage, current, and resistance. So this is just a review for that. Again, Mr. Knott will walk you through. I'm going very quickly because Mr. Knott goes kind of slowly for your sake, so that you can follow along with him. So then you get the relationships between them. Again, that's sort of the whole point of what's called Ohm's law, is that V equals I times R, or I equals V divided by R, and so on. Finally, since V equals I times R, okay, and also I equals V divided by R, and so on, you can work out a few more questions. Finally, we got some series and parallel circuits. That's going to go back to, where we go? There we go. That's going to go back to the original video and a couple other things. So just double check on that. Right. Okay. Make sure you know the difference between parallel and series circuits. We have an example here where basically we talked about it, how if light bulb is removed, for example, if A is removed, then B will go out, because then it's not part of the path anymore, but C, D, and E are all going to stay lit. All right, because A and B are in series with each other, but those two are parallel to these other branches. Okay, so we got 3 branches of our parallel circuit. A and B are in series with each other on one branch. C is all by itself on another branch, and D and E are in series with each other on the 3rd branch. Okay. And finally, explain what's going on. So what does the battery do? You have a voltage source that pushes the electrons, and then you had to have a complete loop of conductors, just like in the thing you did yesterday. All right. Any questions for me? Close that then. Okay. Well, I think what I'm going to do then is, unless there's any questions, I might just close out the stream, keep it nice and short for today. So, all right. Well, if you do have questions, just send me a remind, and I will get back to you as soon as I possibly can, which is pretty quick because, we're at school. I'm working right now, so I'm at school, so to speak. I'm not at school, obviously. I'm at my house. But yeah, so hit me up and I will help you out however I can. Stay safe and stay inside. I'll see you tomorrow.